chapter 4, chemical reactions and chemical quantities. And this is a quote from Linus Pauling, a very famous American chemist. I feel sorry for people who don't know anything about chemistry. They are missing out on an important source of happiness. I think most of my students would not agree with him, but that's what he said. Okay, so this first section is about climate change. Anybody heard about climate change? It's a big topic right now, right? Global warming. So we are going to apply that to chemistry, or apply chemistry to that. First, quick explanation of why carbon dioxide levels matter. So here is an illustration of part of the Earth. And there are gases, they're called greenhouse gases. It's our atmosphere, right? Carbon dioxide is one of them. And the sunlight passes through the atmosphere and warms the Earth. And then when the sun sets, really when we turn away from the sun, instead of all of that heat just being gone to the outer space, the greenhouse gases are going to radiate some of that back. And so they act like a blanket or a greenhouse. A greenhouse, is a glass house that you can raise plants in. And without a heater, it's warmer than outside because it traps the heat of the sun and blocks the wind and stuff. So we need a very tight balance here. We don't want to be too hot, but we don't also want to be too cold. Because if it gets too cold, then you can trigger an ice age, right? And nobody wants that. So this balance between incoming and outgoing energy determines the Earth's average temperature. So at the writing of this textbook, scientists had measured an average 0.7 degrees Celsius rise in atmospheric temperature since 1860. And here's the graph of average temperature of the Earth in different years. And you can see, that's the blue line with the dots. You can see it goes up and down quite a bit. And in fact, there are larger cycles of movement of the temperature. So the red line is the 5-year average. And we can see that, especially since 1960 here, or 70, things are going up much faster than they were, right? So atmospheric CO2 levels during this time have risen 38%. Here we see the CO2 levels, and we see that this kind of mirrors the curve that we're seeing here. And so the question we have to ask is, are the two trends causal, or are they coincidental, right? Did the increase in carbon dioxide cause the increase in temperature? That's a question that's beyond the scope of our class, but we can look at where that CO2 comes from. One source of CO2 is the combustion of fossil fuels, so gasoline, coal, oil, all those sorts of things. And we use a lot of those. And we're generating a lot of CO2. Another source of CO2 is volcanic action. There are natural sources of CO2, and we do need the right level of CO2. If we had no CO2, we'd also be in trouble. So how can we judge whether global warming is natural or due to our use of fossil fuels? And I would say, how can we judge whether the increase in CO2 is natural or due to our use of fossil fuels? Well, we can use a chemical equation that describes the combustion of fossil fuels, and we can use that to relate the amounts of fossil fuels that are burned to the amount of CO2 that is released by those reactions.